Hello everyone, this is Neha Mishra, and along with my team member Raju Nikari, we will present the Lab 1 for Module 2, that is Deep Learning. We are team 14. My class ID is 19 and his class ID is 20. So in this we have two problems in this lab assignment, problem 1 and then problem 2. So we'll start with problem 1. In this problem 1 we are asked to implement the linear regression, and in problem 2 we have been asked to implement the here's problem 2 yes implement the logistic regression. So we'll start with problem 1. Um, this is the code for problem 1. So what we did was we have used abalone.csv as our input file, the data sets for that, and then the same process goes. We read the file, we train the model, and then in the normal what we did was, in the model we have taken sequential model, and then we have divided it in the different activation factors for the different layers. We have used tan and ReLU for the different layers. The losses mean square variation and optimizer we have used as RMS prop. Then we compile the model and then we get the summary of the model. We have used TensorBoard to visualize this output. Then we fit the model according to the test and train data, and then we plot it in the graph. So once I run it, and the epoch we have used is 800 and the batch size is 128. So once I run it, it will take some time, so I'll show it over here. So these are the code snippets that we just went through, and this is the TensorBoard graph that will be shown, and then this is the loss graph that will be plotted. So in the next, and the conclusion is that we see that RMS prop gives us better training loss as compared to the ADAM optimizer, and also epoch and learning rate plays a very significant role in the same, because you can see the evaluation sheet over here for the different evaluation factors. We have changed the hyperparameters for each time, and then we got to know the conclusion. For the problem 2, where we have the regression test, logistic regression, over here we've used the inbuilt, it's still running. So over here we have used the inbuilt minstrel data set. It is the same logic. See, this is the graph that has been plotted. So in the okay, so the model is a sequential model. Then we have used the optimizer as SGD. Well, that is where it is divided into 4 different subparts, in which we have changed these hyperparameters in each of the part, and then we got to know which one is better in terms of accuracy and loss. So for the first one, we'll take epoch as 100, NB class is 10, and batch size is 128. Here the optimizer is SDG, and in the second one we have the same batch size, epoch and classes, but we have used the optimizer as RMS prop. In the third one we have reduced the epoch to 20, batch size is 50, and NB class is 10. Here the optimizer again is SDG. In the fourth one we have used the same optimizer as SGD, but we have increased the epoch to 100. So we ran all these 4, and over here we have attached the code snippets that we just went through, and then we can see that with these parameters the conclusion was accuracy was 0.92, 0.93. Well, in case of each parts that we just went through, this is the accuracy and this is the loss. So we get to know that optimizer SGD is a bit less, is a bit better, and when we have less batch size and less NB class compared to others, so we get slightly more accuracy when epoch is 100. So that's it. Thank you.